Hello everybody. The events of the last couple of videos have reignited another interest of mine, and that's dial-up modems. And so we are going to look at another external serial modem that I have today. This is a US Robotics Courier 56K business modem. That's what they called it. And this was actually made in 2005, making it very late in the grand scheme of modems, especially big external desktop serial modems like this is. Now, if you have a good memory, you might remember this thing for a very comical reason. I bought this on eBay in 2021, and it was the subject of a 2-hour live stream after I got it because it arrived in the mail completely destroyed. It was sold to me as a perfect working, good condition modem, looked great in the photos, and when I got it, the plastic casing was just shattered in multiple pieces rather, and it was just insane. I had never seen anything like that. I had never had something bought from eBay come in such bad condition. Amazingly, the circuit board survived, and this works just fine. And as you can see, also amazingly, I was able to piece it back together like Humpty Dumpty just fine too. And that's what I did in that 2-hour long live stream in 2021. If we look at it here, you can see some of the seams where I epoxied this back together using Permatex plastic welder. And if there was ever a good example of how good that stuff works, this is it, because 3 years later, it is still in one piece. That's pretty impressive. And so today, we are finally gonna look at this modem. We'll demonstrate it. I'll hook it up to a phone line. We'll make a few phone calls to a few different types of devices and services with it. And it should be pretty cool. Now, the reason I'm making this video today is because this modem's actually going away. It's kind of redundant in my collection. I've got another US Robotics Courier modem that I like to use. The reason I bought this one at all is something we will talk about in a few moments. But yeah, I've been kind of fixing to get rid of this thing, and I am sending this off to my friend and a friend of the channel, Braden. Braden is the person who sold me the Northern Telecom Norstar compact ICS key telephone system that now hangs on my telephone wall. And I will use this opportunity to announce that my old Norstar, my Norstar 6x16, is currently for sale on eBay. I thought I was going to finish the video series on the 6x16. I've decided not to, and just to commit my time and energy to this unit. So link in the description if you're interested in buying my old Norstar 6x16. But Braden was the one who sold me the compact ICS, which I'm using now. And, you know, it's funny. After the video of the Leach CSD 5300, I've gotten almost 50 calls to the CSD 5300, which is amazing. About half of them, well, maybe 3/4 of them are people calling from a modem, from a computer. And then maybe 1/4 of the calls were people just calling from a normal telephone just to hear it spit its carrier tone at them. But I got one call that was kind of amusing to me. It was somebody called the CSD 5300 from a fax machine. The call came in, and you could hear the beeping that a fax modem sends out to let the remote modem know that it's a fax machine. And it turned out that it was Braden making that call from a fax machine, and he did it because it's the only thing with a modem that he owns. He doesn't have a computer with a modem or a standalone modem. And in case you're wondering, if you call the Leech CSD 5300 from a fax machine, nothing will happen, no connection will be made. But yeah, when I heard that it was him and he did it because he doesn't have a modem, I thought, hey, I'm fixing to get rid of this thing. How about I just spread the love and send it off to him so he has his own modem. I think that's a pretty neat idea because I love singing the praises. You know, I don't think people realize these days how much you can do with a dial-up modem with very little technical know-how needed and very little money needed either. They're very fun to play with. So this is going to him, but before we do that, we're going to take one last look at it, do a proper demonstration of it, and see what it's all about. Now, this is a V.92 modem. V.92 was the final modulation standard for analog dial-up modems. It's 56K, 56 kilobits per second down, 48 kilobits per second up. Yeah, and V.92 was published in 2000. It was the second standard 56K modulation, the previous one being V.90 in 1998. But there were two proprietary 56K modulations that were not ITU standards. Those were X2 and K56 Flex, and those came out in 1997. It was very common for the modem manufacturers to come out with their own proprietary modulation schemes that were faster than whatever was standard at the time. US Robotics were the developers of X2, and then Rockwell and a few other manufacturers were behind K56 Flex. And V.90 kind of ended that proprietary modulation war, came out with a standard 56K modulation that both X2 and K56 Flex modems could be upgraded to support without any change of hardware needed. V.90 was similar enough to those two proprietary modulations. But this guy, in addition to all those other 56K modulations, it also supports V.92. And the reason I bought this, I actually bought this in addition to another V.92 modem, which we'll also look at someday. That one's a US Robotics Sportster. And I bought two V.92 modems because I wanted to play with having a V.92 connection between two modems. And what I did not know at the time, which is kind of interesting but also kind of annoying finding out after I bought two modems, two ordinary 56K modems, doesn't matter if it's V.92, V.90, X2, or K56 Flex, two 56K modems will never be able to connect to each other at 56K. They will only be able to connect to each other at V.34 modulation, that's 33.6K. A 56K modem can only connect at 56K to ISP grade equipment or to a digital modem connected to an ISDN line. ISDN being a digital standard for telephone communications that was carried over an otherwise ordinary telephone line, but it was digital instead of analog. Back in the 80s and early 90s, everybody thought ISDN was going to be the huge thing. They thought the entirety of our telephone network would become ISDN. Never happened. It was kind of a flop. But a 56K modem can only connect at 56K to a digital modem that's attached to an ISDN line, which also includes ISP dial-up access equipment. Now, why is that? Well, it all comes down to the limitations of the telephone network. Now, the old electromechanical telephone network from before the 1980s, the signal path was entirely analog. You picked up your phone, called a phone number, and you would have an entirely analog connection to the remote phone. Starting in the 1960s, your phone call may be converted to digital to go over a long distance line. That's where modulations such as T1 and E1 originate from. But at least for local calls and medium distance calls, it was an entirely analog signal path. But starting with the newfangled computerized telephone exchanges in the 1980s, such as the Western Electric 5ESS in the United States or the Northern Telecom DMS 100 here in Canada, when you made a phone call, your call was actually converted to digital at the exchange. And that digital form of your phone call had a finite quality, as all digital things have to have. These new digital phone calls had a sampling rate of 8 kilohertz and a resolution of 8 bits. And that's where the standard phone call quality of 8 bits, 8 kilohertz comes from. It goes all the way back to the digital telephone exchanges. Now, the problem is an 8 kilohertz wide, 8-bit digital sound signal is technically enough to carry a 56 kilobit per second data connection. Actually, it's enough to carry a 64 kilobit per second data connection. But because the modem is an analog device and it starts on the analog side of things, and then the call is converted to digital and then converted back to analog when it reaches the remote modem, that conversion from analog to digital to analog does not support that much data. It cannot support 56 kilobits per second of data. It's just impossible to do due to Nyquist theory and everything else that comes with the conversion of something from analog to digital and then back to analog. It just can't support that much data. So the highest supported modulation is 33.6K, V.34. But if I take this modem and I call a digital modem with it, which might be an internet service provider who provides dial-up internet from modems connected to an ISDN line, or the modem manufacturers, including US Robotics, they actually sold consumer-grade digital modems that connected directly to an ISDN line. But as long as I take this modem and I call one of those digital modems with it, there is enough quality in the call. There's enough bandwidth to support a 56 kilobit per second connection because the signal is only going from analog to digital. It's not going from analog to digital to analog. So you don't ruin the data carrying capability of the call by having that double conversion. Likewise, when data is coming back to you, it only has to go from digital to analog, not from analog to digital to analog. And so that's why two 56K modems will never be able to connect to each other at 56K. Even if the two modems are actually connected to each other with an entirely analog signal path, they will not connect at 56K. The first thing a 56K modem does when it calls a remote modem is it asks it, are you an analog modem or a digital modem? It does this as part of the V.8 portion of the handshake near the beginning of the handshaking sequence. And if the remote modem says, I'm an analog modem, it immediately aborts any attempt to connect at any 56K modulation. It falls back to V.34. If the remote modem says, I'm a digital modem, because it's either an ISDN modem or it's an actual ISP grade 56K modem connected to a ISDN line, then it will attempt a 56K connection. So it's kind of neat why it all works that way, but it's also kind of annoying because I bought two 56K modems and it turns out using them together is no better than using two 33.6K modems. Oh well. Now because of this, and of course there's lots of dial-up BBSs today that you can call with a modem, and like I said earlier, there's lots of ways to have fun with these, but the ability to make a call with one of these and have it actually connect at 56K is starting to become extinct, at the very least endangered. because the only way you can get a 56K connection is if you have some of that really expensive ISP grade gear and then an ISDN line to connect it to. And doing all that is not cheap and not necessarily easy to do. But we will be able to at least attempt a 56K call with this modem later in this video, because someone actually procured some ISP grade ISDN modems, and they set up a dial-up gateway for anyone to use. And when you dial into this gateway, there's different BBSs that you can connect to. It's called the 2600 network. And you can read about it if you go to the website 2600.network. That's 2600.network. And it's pretty cool. And aside from pestering one of the few actual existing dial-up ISPs by making calls from your modem, this 2600.network is pretty much the only way to actually test a 56K modem with a 56K connection. So it's really cool that the person or people who procured this equipment make it available to use. So we will try dialing into that. Actually, I'll spoil it right now. It's probably not going to work. It's very hard to get a 56K connection from a VoIP telephone line. And actually what I found is that I can't reliably dial into the 2600 network at 56K. The handshaking actually doesn't even finish on this modem. My other V.92 modem actually will connect to the 2600 network at V.92 without issue, but this guy does have a bit of an issue. But I did find an ISP that this will connect at V.92 too, so we'll dial into that later. So before we start dialing away with this thing though, let's take a look at it. Now, if you watched my video on the US Robotics Courier V.everything, this might look a little familiar, and indeed it's it's pretty darn similar indeed. They're exactly the same shape. The biggest difference you can see, aside from the labeling, is that the lens for the LEDs on the newer modem, it's much lighter, a much lighter red and kind of opaque looking versus the V.everything. You can also see we got the old US Robotics logo, and then the newer one. I don't know about you, but in my opinion, I think the older logo looks a lot cooler. But physically, they're very similar. You've got all your LEDs on the front. If you want an explanation of what these LEDs are, you can watch my video on the US Robotics Courier V.everything. And you've got your voice data button, and of course, like the V.everything, this button is actually programmable. You can program the modem to do literally anything when this button is pressed, which is very nice. And you look around on the back, you got your DB25 serial port. And you've got your RJ11 jacks, one to plug your telephone line into and one to plug a standard telephone set into. And your power switch is a push button on this unit versus a rocker switch on the older Courier. Standard barrel jack for power. This modem can take actually a wide range of voltages. I just recently found this out because the V.everything specifies 9 volts AC, but this guy will accept, it says 20 volts AC, but there's a big range there. I can tell you it's at least 9 to 20, or 12 to 20 volts DC. So very easy to power one of these. I always knew that you could put 9 volts DC into a Courier modem and it'll work fine. The only reason Couriers have a 9 volts AC input is because the power supply circuitry is housed inside the modem itself. It's just better interference-wise than having the power supply circuitry inside the power brick. So the power brick's just a transformer. So with this modem and the older V.everything, you can plumb 9 volts DC into them and it'll work fine. But with this guy, it actually specifies DC and it says 12 to 20. So very easy to find a power supply that'll work with one of these. And polarity doesn't matter either, because there's a rectifier in here already that converts it to the right polarity. So there you go. Also on the bottom, there's the model number of this, 3453B. It was made in China, whereas the older Courier was made in the USA. It's got a ringer equivalence number of 0.6. That's how much load it places on the telephone line when the line rings. And it's funny, right here it says input 15 volts DC, 0.8 amps. It's funny that it specifies a specific voltage. You've got your dip switches for setting various things, such as whether to override data terminal ready detection, how you want result codes to work, whether or not you want it to echo things you type into it in command mode, just in case you're using a terminal that does its own local echoing. Turn auto answer on and off. You can override carrier detect, so it just always assumes that it's hearing a carrier signal. Enable or disable the AT command set. Whether or not a call is disconnected when you type the escape sequence. And when the modem powers on, do you want it to load whatever settings you've stored in memory, or do you want to just load the factory defaults? And again, I explain all that stuff in greater detail in my video of the Courier V.everything. Speaking of the name V.everything, so US Robotics marketed this modem, like on the box for the modem. It's called the US Robotics Courier 56K Business Modem. But as you can see, it actually doesn't say Courier anywhere on it. You have to look at the bottom of the sticker before you see right there, Courier 56K Business Modem. And but in the firmware of this modem, if you type one of the ATI commands, we'll see later, this actually identifies as a Courier V.everything. And technically, it is a Courier V.everything. What does V.everything mean? Well, it can connect at any modulation scheme, standard or non-standard, with the exception of the non-standard modulations that US Robotics never supported. So you've got all your standard modulations, V.34, V.90, V.92, V.32, V.32 bis, etc., etc. It'll connect at V.22 bis, that's 2400 bit per second. It'll connect at Bell 212A, 1200 bit per second. It'll connect at Bell 103, 300 baud. And for the non-standard modulations, it'll do V.32 turbo. It'll do HST, which was US Robotics' own proprietary modulation scheme. And it'll do V.fast class, which was a non-standard modulation scheme while the modem manufacturers were waiting for V.34 to be published. So all the standard and lots of non-standard modulation schemes, this thing will make calls at those modulations, and it'll receive calls at those modulations. And we'll see when we dial some numbers with this thing later, just how effortlessly it connects at all those modulation schemes. Now, kind of the amazing thing is that US Robotics made this modem for a long time. They made it well into the 2010s, and actually you can still buy one of these today. However, US Robotics doesn't manufacture these new anymore, but what they're doing today is they're refurbishing them. And they're selling them as refurbished units. They're even giving them their own model designation, the 3453C-REF. So it's kind of amazing that you can still buy one of these today. And you might think that it's a little crazy that you can still buy one of these today, but actually it's not that surprising when you learn how much industry today still depends on dial-up modems. There's so many industries, government, medical, science, engineering, that has a lot of legacy equipment that needs to be remoted into with a dial-up modem. But also, a lot of people buy modems like this and just use them for faxing. Faxing is still super common today in industries like insurance, legal, the legal industry, again, medical stuff. Actually, at my old job, one of my tasks was to set up a PC and install a dial-up modem in that PC, and it was purely just used for receiving and sending faxes. And yeah, I bought this refurbished Dell Optiplex PC, and I bought a US Robotics PCI Express modem. Yep, you can get them in PCI Express flavor. It would have been a lot cooler if I had bought an external modem like this, but the PCI Express version was much cheaper. And I was working on a budget, of course. But yeah, there's still a market for dial-up modems in general, whether it's just faxing or if it's for an industry where you actually need to connect to a computer or a machine over a telephone line. It's very, very neat. And so yeah, US Robotics are not only still refurbishing these and reselling them, their Sportster dial-up modem, the V.92 Sportster, they're still making those, at least according to their website, they're still making them new. So it's very, very, very neat, if a little funny too. So, with all that being said, let's prepare a computer, hook this thing up, connect a telephone line to it, and we will dial some numbers and watch and listen to this thing make some connections. All right, we are sitting at the Epson Apex Plus. I've got the modem plugged into the serial port on the computer. I've got it turned on, as you can see, and we've got two lights on, the modem ready light and the clear to send light. And I'm going to run BananaCom. It's my terminal emulator of choice on any DOS PC or even a PC running Windows 95 or 98. I think it's an excellent terminal emulator. And you can see once BananaCom opened, we've got two new lights lit up on the modem, the request to send light and the data terminal ready light. When BananaCom opened, it brought up the data terminal ready pin on the serial port, and that just tells the modem that there is a terminal running and ready to send and receive data to and from the modem. So, we are going to start by running the ATI commands. That's where the modem will spit out information about itself, at least if the programmers were generous enough to provide that information in the modem's firmware. So we'll start at ATI 1. I don't know what that is. That might be some sort of hardware revision. 2 is nothing. So ATI 3, it calls itself a US Robotics Courier V.everything external. And if this were an internal modem, and there are internal courier modems in mostly ISA, but I think there were PCI ones too, it would call itself a V.everything internal, INT. So ATI 4 is when we start getting a bunch of information. It shows us a bunch of settings, what the baud rate currently is, whether or not we're using parity in our serial connection, what the data, how many data bits are in our serial connection, 8 data bits. I don't know what dial equals hunt means. Shows the current hook status of the modem, and I don't know what timer means. The next 2 lines below that, I'm guessing they are showing what settings are set that you can set by using the AT ampersand commands. And then the big block of text below that shows us all the settings of our S registers. And we're going to be poking the S registers here in a moment for a specific reason. And then finally at the bottom, it shows us the number that was last dialed since the modem has been powered on. We go to ATI 5. It's a lot of the same stuff, but now towards the bottom, it shows us the contents of the phone book. So like most high-end modems, this has an onboard phone book. You can store 10 phone numbers in its non-volatile memory and then use an AT command, I forget what command that is, to call those numbers, which is very nice. I might program a couple of those in before I send this modem off to Braden. And then at the bottom, it shows us the command that is stored in the voice data switch. So in this case, it's ATH. So pressing the button while the modem's on a call will hang it up. And I think while it's off hook, pressing that button will actually bring it on hook and actually put it into answer mode, I believe. So move on to ATI 6. ATI 6 gives us statistics for the last call that we made with the modem. So how much data was lost, how much was sent, received, how long the call went on for, what kind of compression was used, all that sort of stuff, which is kind of cool. ATI 7 gives us a bunch of hardware information about the modem. It's a North American external modem. We've got the product ID. You can see 3453 in there, and I bet the 02 at the end signifies that it's the B revision. What modulations are available? Well, we've got HST, V.32 bis, V.32 turbo, V.fast class, V.34 plus, which was another sort of interim pseudo standard that the modem manufacturers made while they were waiting for the 33.6 kilobit per second revision to V.34. V.90 and V.92, and of course that's in addition to all the other older modulations. What fax modulation standards are available? Clock frequency of the CPU, 25 megahertz. It's actually faster than my Courier V.everything. That's only 20 megahertz. Flash ROM, we seem to have dropped a character in the serial connection. That should say 1024K. How much RAM we've got. And the date of the hardware, it's actually 2004 and 2003 for the DSP chip, but I do know for a fact that this modem was manufactured, or at least assembled, in 2005. And you get the firmware version, serial number of the unit. If we go to ATI, I forget where we were at. Oh, we did 7, so we're at 8 now. 8 is an error. And ATI 9, we get whatever that is. Might have something to do with the firmware. And then there's actually even more ATI commands on this modem. ATI 10 to 17 displays info about dial security, which I don't really know anything about, more link diagnostics, and other additional info. So that's all the ATI commands. Now, this modem is currently connected as an extension on the Norstar system, and connected as another extension on the Norstar system is my Courier V.everything. So we're going to start by just calling the V.everything, and we'll just do it right off the bat, and then we'll do it a few more times, but doing something a bit cool each time. So I'm going to go ATDT, I think it's on extension 21, and you'll get to hear this thing handshake. There you go, very standard V.34 handshake, and you can see on the screen we did connect at 33.6K. We've got ARQ, it shows us our modulation, V.34, and we did get LAPM, which basically denotes V.42 error correction. So, there we go. Now, I'm going to hang up the call. I'll press the button on the modem here. There we go. Now, we can change the settings in the S registers of the modem to basically make it emulate an older modem with older modulation available. And in today's world, where you're going to be using a modem on a VoIP line, it's actually very useful to be able to know how to do that, because and it's just an unfortunate reality of VoIP telephone lines, at least ones that you can get from affordable VoIP service providers like the one I use, VoIP.ms. The faster modulation schemes just don't work that great on VoIP lines. And a lot of it's actually just in the handshake. The data stream itself might work okay on a VoIP line, but because of the delay and stuff like that, sometimes two modems just can't even handshake on a VoIP line. Either the handshake will fail, or the handshake will finish, but the call will drop soon after. So if you have a newer modem like this one, it's really useful to know how to make it emulate an older modem, because the older modulation schemes, they're obviously slower, and so they work better on a VoIP line. Also, the handshakes just seem to work better on a VoIP line. So I'm going to go through a bunch of that here with this modem, and you can see how we do that. Now, it's different. The S registers you have to set are different for every modem, and actually for this modem it's very weird. Actually, when I first got this modem, I thought something was wrong with it, and it just wouldn't connect at V.32 or V.32 bis. And I've only recently discovered that it will do that. It's just that the S registers you have to set are very strange. But anyway, we'll learn here as we go along. So I'm going to start by making this modem emulate a V.fast class modem. V.fast class was a modulation scheme devised in, I think, 1994. And it is not a standard modulation. It is a proprietary pseudo-standard modulation that was developed by a bunch of the modem manufacturers while they were waiting for V.34 to be ratified. So V.fast class gets you up to 28.8 kilobits per second at a time when the fastest standard modulation was V.32 bis, which is only 14.4K. So this was twice as much data than the fastest standard modulation at the time. So to make this modem emulate a V.fast class modem, we have to set ATS54 equals 128. And it says OK. Now what does that mean? What did we just do? Well, if we go ATS $ to get a dictionary of the S registers, ATS54 equals 128. Well, there's S54 on the right. And setting that to 128 basically disables V.8. V.8 is part of the handshake sequence. It's the part near the beginning of the handshake sequence that's frequency shift keyed. I think it's a 300 baud transaction. It's a short communication between the two modems where they list the various modulations and data correction and compression standards that they support, so the two modems know what their capabilities are. V.8 only came about beginning with V.34, I believe. And of course it's used in V.90 and V.92. So by disabling V.8, we've essentially wiped out all those faster modulations. So this modem, as a result of that, Control C here, this modem as a result of that is now going to emulate a V.fast class modem. Now, not every modem supports V.fast class. It was a pseudo standard, so only high-end modems support it. Your consumer grade modems like a US Robotics Sportster never would have supported V.fast class. But the Courier V.everything that we're going to call does. So we will connect at V.fast class. If the modem I was connecting to was not a V.fast class, it would actually fall back to V.22 bits. That's 2400 bit per second. But we're going to connect to a V.fast class modem, so it's all good. Now, if you've never heard of V.fast class handshake, and most of you probably haven't, it's pretty gnarly. It is one of the more unique modem handshakes that exist. So let's hear what it sounds like. And there we go. That was a V.fast class handshake. And you can see here in the result, we did connect at 28.8K. We've got ARQ, we've got LAPM, and of course it's showing VFC for the modulation. So there you go. Let's do that one more time. I'll hang up this way. I'll enter in the escape sequence, +++, and ATH. We've now hung up. The first time I ever heard of V.fast class handshake, I wasn't trying to do it on purpose. I didn't even know what V.fast class was. I called a BBS, and for some reason, it's the only time it ever happened, the modem serving that BBS decided to connect at V.fast class, and I couldn't believe it. It was the first time I ever heard it. But there we go. So, that's V.fast class. Now, next we're going to emulate an HST modem. HST was US Robotics' own pseudo standard. US Robotics actually came up with it back in, I think, the late 80s while they were waiting for V.32, the 9600 bit per second standard, to be ratified. And US Robotics actually updated HST over the years. They always updated it to keep it ahead of the actual standards. And so I think the fastest version of HST is like 21.6 kilobits per second or something like that. So to make this thing emulate an HST modem, we have to set S54 to 128. We've already done that. And we also have to set S56 to 224. So what did we do just now by setting S56 to 224? Let's find out. So 224, so a lot of these registers like S54 and S56, you can see they're bit mapped. And so when you type in that number, like setting it to 224, you're typing in a decimal value that gets converted to a binary value, and that turns on and off the various features. So by setting S56 to 224, you can see we're disabling V.fast class, we're disabling V.34, and we're disabling V.34 plus. Now, for some reason, even though I disabled V.8, I still have to specifically disable V.34 and V.34 plus in addition to V.fast class for HST to work. I don't know why. It's one of the many things that doesn't make sense with this particular modem with the register settings. But anyway, that's what we're doing when we set S56 to 224. I think did I do that already? Yes, I did. So you can see I typed AT S56 query, and that means tell me what's currently in S56. So we're now ready to emulate an HST modem. So I will call the v.everything again, because of course it also supports HST. So an HST handshake is not, it's not exciting at all. It sounds just like a Bell 212A or a V.22 bis handshake. But you can see we connected at 6.8K. We've got ARQ once again, and HST, and it says HST twice for some reason. So there you go. So next, we're going to emulate a V.32 turbo modem. V.32 turbo was another pseudo standard that people came up with while they were, it actually competed with V.fast class. V.32 turbo and V.fast class both came out in, I think, 1994. They competed with each other. Some of the modem manufacturers supported V.32 turbo, some supported V.fast class. US Robotics, good guys as they were, they put support for both in the Courier modems. You got your money's worth. V.32 turbo was not as good as V.fast class. The fastest speed for turbo is, I think, 19.2 kilobits per second or something. Actually, even I read a PC Magazine article from 1994. They straight up said, we don't know why V.32 turbo exists since V.fast class existed. I guess it was because V.32 turbo could be implemented on existing V.32 bis hardware without any changes to the hardware, whereas V.fast class actually required the new generation of hardware. Basically, V.fast class was basically a beta version of V.34. So turbo was easier to implement on existing hardware. So to emulate V.32 turbo, we set S54 to 128, already done it. Set S56 to 224, we've already done that. And now we're going to set S58 to 96. And by doing that, 96. So we disabled V.92 and V.90. Again, I have no idea why we needed to do this. Like, why did we, how did disabling 92 and 90 make it decide that it's going to connect at V.32 turbo now? Like, why didn't I have to disable HST? That's the weirdest part, is we don't have to set the register to disable HST, even though I believe there is a register to do that. Very, very weird on this modem. It all makes sense on the older Courier, the V. everything. It doesn't make sense on this modem. But anyway, I figured all this out. I'm actually going to send this modem with a paper to Braden with all the registers to set on how to make it emulate a slower modem, just because it is important to do on a VoIP line. So we're ready to connect at V.32 turbo modulation. So let's dial again. Sounds just like a 32 bis handshake. So yeah, nothing exciting there either, although I do enjoy the V.32 handshake. It's one of my favorite handshakes. Okay, I had them switched. I guess HST is I thought HST went up to like 21 point something K, but it's actually turbo. So we're connected at 21.6 K, ARQ. Shows V.32, it'll show that whether it's 32 bis or 32 turbo. And once again, we have LAPM error correction. So there's that. Now, naturally, the next step slower is V.32 bis, which is 14.4 K. And we're going to do all the same that we've done before, but we're going to set a new register, S34 to 128. And I can already tell you without having to look what this does. This literally just disables V.32 turbo. So we do that again. And there we go. All the same. And then next after that is V.32 itself, the 9600 bit per second modulation. And we're going to actually change S34. We set it to 128. We are now going to set it to 131, which if I remember right, just means disable turbo and disable V.32 bis. And I think it also disables enhanced V.32, whatever that means. Dial again. There we go, all the same. So next step is V.22 bis, that's 2400 bit per second. And some things are going to change. S54 will stay at 128, S56 will stay at 224, but I'm going to set S58 back to whatever it was before, and I forget what that was. I didn't check to see what it was by default. So we're going to start by just doing a factory reset of the modem. AT ampersand F1 executes a it basically tells the modem, go back to all factory default settings. So we're going to do that. All the register changes we made have now been reversed. So I'm going to do this and that. Now we're going to set ATS27 equals 4 and ATS13 equals 32. Now, what does that mean? So by setting S13 to 32, we've disabled HST. Why we had to disable HST now, again, it doesn't make sense to me, I'm not sure. And then S27 equals 4, we've disabled V.32. So, dial again. And there we go, 2400 bit per second, ARQ, and we still have LAPM. Now, I could have achieved the same thing by actually setting the serial port speed to 2400 bit per second. If I do another reset, this will actually achieve the same thing. You can see. Now you may ask, well, can I just set the serial port speed to 9600 to get V.32 connection? And the answer is no, because V.34 actually supports down to 9600 bit per second. So if I make a call with the serial port set to 9600 bit per second, it will handshake at V.34. And on a VoIP telephone line, that may not work. So it actually is better to set the registers to actually force an actual V.32 handshake and a V.32 connection. But for 2400 and slower, that works. So if I force the serial port down to 1200 and dial again, we've made a Bell 212A connection, and it even works down to 300. 300 baud, Bell 103, dial again. And there you can see we've made a Bell 103 300 baud connection. We don't get any features like ARQ or any error correction or compression because A, Bell 103 modulation doesn't need it, and B, those functions were never implemented into Bell 103 modulation because it doesn't need it. But there you go. Now, so using Bell 103 as an example, forcing the serial port down to 300 baud will force the modem to connect at 300 baud, but the hallmark of any good modem is to be able to connect to slower devices. Some bad modems, like crappy soft modems that are built into like laptops and that even come on some ISA or PCI cards, if they're new enough, they will not connect at slower modulations. They'll just assume that anything they'll ever call is a V.34 or V.32 whatever modem. And if I wanted to call something like the Leech CSD 5300 on one of those crappy modems, the handshake will fail. The modem will just not connect to it. But any good modem, like a US Robotics Courier, or even most you know, controller-based modems, as in modems that aren't soft modems, they will connect to ancient devices just fine. So you can see I've set the serial port back up to the full speed. I will once again reset everything. And I have the Leech CSD5300 also connected as an extension on the Norstar system. So even though this modem is a super modern V.92 modem, it'll have no issue connecting on a Bell 103 device like the Leech CSD5300. So let me demonstrate. I believe it's extension 37. And there we go. And as you can see, we are connected to the Leech CSD5300, no problem. It works just fine. Now, what you heard there, the handshake might have sounded a little odd. So, Bell 103, Bell 212A, and V.22 BIS, they all use the same answer tone. So, when a device using one of those three modulations picks up the phone, this modem has no idea if it's connected to a Bell 103, Bell 212A, or V.22 BIS device. And so it'll start by assuming the fastest, and so that's, you know, staticky sound you heard was it attempting to handshake at V.22 BIS, and when it didn't get a response from the remote modem after a few seconds, it fell back to Bell 103. And any good modem will be able to do that. So that is how that works. So we successfully connected to the Leech. How about we actually get out into the world? I've just been calling extensions on my internal telephone network here. Let's actually call out into the world. Let's call a BBS. Now, there are so many dial-up BBSs. Here's a big list of them. And this is only some of them. And it's great that so many people are figuring out that, hey, you can still do things with dial-up modems, and it's super cool and fun to do. And it's easy to work around the issues that can crop up. So my personal favorite BBS is Klooge. Klooge is run by a guy down in the States. I follow him on Mastodon, and Klooge actually runs on a Macintosh Plus. And it's just got an ordinary modem connected to it, and the software's custom written software. He wrote the BBS software himself, and it works super well, really easy to use. A lot of BBSs, they're just so hard to use. I think people just take the default template that comes with the software and they never customize it. But Klooge is really straightforward to use. It's very nice. Also, Klooge has probably the best connection of any dial-up BBS that I've used. I quite reliably connect at V.34. Which is a little unusual. Most of these BBSs, I have to knock it down to V.32 BIS or Turbo. But Klooge, I have no problem with a V.34 connection. He might be on VoIP.ms as well, so being able to call within VoIP.ms's own system may be why, if that's the case, that would be why it works a bit better than most. So let's call Klooge. Now, it's not going to work when it dials because I'm inside. I'm on a Norstar extension, and so I actually have to dial my access code to get out onto an external line. So I'm going to have to hang up as soon as I hit return here. There we go. And so what I really need to do is ATDT. I'm going to use line 262, comma 31265400090. Now, really what I should be doing is directly connecting the modem to one of my outside lines. But and that's because the Norstar itself is a digital network. So instead of this phone call going from analog to digital to analog, it now has to go from analog to digital to analog to digital to analog. So this might actually not work well at all. It may be, I'll actually be surprised if it still makes a V.34 connection. But let's try it. Oh. That's weird. Why didn't my access code work? That is the line pool code, isn't it? Am I dumb? Did I unplug something? I don't think I did. Let me just do this. Oh, that's interesting. We're off script. A problem has occurred. Okay. That line works, but I don't want to connect it that line. Does the Leech's dedicated line work? Yes. Oh, why doesn't line 2 work? Oh, isn't that funny? Okay, I will use line 1 then. 312-654-0090. The comma, as you can see, is a pause. Oh yeah, it's struggling. Oh, it might do it. Oh. Oh no. It actually handshake. That was a very strained handshake. I'm gonna disconnect. Because we obviously had problems. Let's give this a fair shot. I'm going to directly connect this to my ATA instead of going from the Norstar system. Okay, we're good. So I'll do this, and maybe now we'll get a good connection. Nope, that fell on its face. All right, let's knock it down to V.32 bis. I don't want to waste everybody's time watching me try and do this and making a liar out of myself. Yeah, 15. But it's a good demonstration on how knocking a modem down to a slower modulation tends to be necessary for VoIP lines. Oh, are you not going to pick up my call now? Oh no. And there you go. V.32 and V.32 bis, they're pretty reliable on a VoIP line. to the point where I would almost recommend to someone to just buy an older V.32 or V.32 bis modem. So you can see we actually connected at 9600, but you can see running on an 8 megahertz Macintosh Plus. That's pretty cool. I forget if that's my password or not. Haha. Yep. Yep. I'm the 7th caller today. There we go. Who's logged in recently? Just a bunch of guests. All right, so there you go. We've connected to a BBS. There you go. So we'll log off here. Goodbye. There we go. So there, we've connected to a BBS. Now, I should have dug out a Windows, 95 or 98 machine to demonstrate this with, but I can still call the number. Another friend of the channel, Mike Dank, he runs a dial-up internet service that's free to use. It only costs whatever the phone call costs you. And you can dial into that on any computer with dial-up internet support, and it works just like any other dial-up connection would have made at the time. So I've got no software on this to make a PPP dial-up internet connection, but I can still call the number and the modems will still handshake. So let's do an AT ampersand F1, get our default settings back. And his number is 484-820-1337. You can go to dialup.world. That's the website where you can get information about this. But let's see how well this modem connects to dial-up world. And there we go. The handshake struggled a bit, but we actually got a V.34 connection. Mike is on VoIP.ms. I know that for certain. So this works pretty well as well. Oh, I forgot about this. He actually, whoops, that's too many Zs. He actually, this number actually provides access to some BBSs as well. So we can log into the level 29 BBS from Mike Dank's number, which is pretty cool. So there you go. We've connected. Level 29 is a great BBS. It might be one of the biggest BBSs, like one of the most active. Like Kluge is my favorite, but level 29 is one that I highly recommend as well. Certainly, it's one with more stuff going on, just because of the amount of users. So there you go. So we will hang up on that. Now, let's make a V.92 connection. So, like I said earlier, there is a network of BBSs that all share a single dial-up gateway. This gateway has several modems. And they are real ISP grade digital V.92 modems. So hopefully we'll see how it works. We can actually do a V.92 connection on this modem. Now, this particular modem I have not had luck connecting to this BBS network at V.92. But if it fails, I have another number I can call that I have managed to get a V.92 connection. V.92 is extremely, any of the 56K modulations are extremely hard to connect at on a VoIP line, just because a VoIP telephone line just really doesn't meet the requirements needed to carry that much data. So, but we're going to try here. We're going to dial 760-330-2600. This is one of the many numbers that gets you into the 2600 network. Yeah, this is what it does. So we did connect, but it's not at V92. We've connected at V.34. So, and what the 56K modulations, or at least V.92, what it'll do is, if it would appear, or at least that's what these particular digital modems do, if the V.92 handshake fails 3 times, you can hear it made 3 attempts, or I guess 2 attempts, it'll fall back to V.34. So this didn't work. I'm not going to try it again because I've tried many times and didn't get it to work, and I don't want to risk getting my number blocked by this network of BBSs. So I'm going to pull up another number. This is the number of an actual dial-up internet service here in Canada. It's one run by a nonprofit. I'm going to obscure the number because I don't want people inundating them with calls. Darn, that was so close. Oh, and it hung up even. That was very close. We actually got to the digital impairment learning part of a V92 handshake. You heard that bong, bong. That is a portion of a 56K handshake called Digital Impairment Learning. This modem is sending digital data to the remote modem, telling it to make a certain sound. And then it's the remote modem that's actually making that bong sound, and this modem's listening to that bong sound to see how accurate it is compared to what it asked the digital modem to make. The digital impairment learning is not standardized. What the sound actually isn't standardized in any of the 56K standards. So every brand of modem will ask the remote modem to make a different noise. And US robotics modems ask for the remote modem to make that bong sound. And so you know when you're using a US robotics modem because on a 56K connection, it will request that bong sound. Every modem manufacturer is different. Rockwell is probably the most well-known one. Motorola modems make a very weird digital impairment learning sound. And so I actually have a Motorola soft modem. I'm hoping I can maybe make that, get a 56K connection out of that. So we got really close, but no cigar. I don't want to bug this ISP anymore. I'm not going to make any more calls, but just pretend it said connect, 48 whatever /ARQ /V92 /LAPM /V.42 bis. You heard all the handshake though. That was the entire handshake. It just it wanted to retry for some reason. But there you go. So that's a bunch of just a whole bunch of examples of stuff we can connect to with this modem. I connected to another older Courier modem. We connected to the Leach CSD 5300 for a Bell 103 connection. Connected to a BBS. We connected to Mike Dank's dial-up provider, and we connected to a commercial, well not commercial, a non-profit, but still paid a dial-up internet service provider. And you heard an entire V.92 handshake, even if the call failed ultimately. So there you go. Well, that's all there is to show of the US Robotics Courier 56K V.92 external modem from 2005. And I originally intended this video to be just a quick demonstration of the modem, just so I could get it sent off. But as usual for me, it turned into something quite a bit bigger than that. But I think I've divulged some good information in this video, being able to show how to make this modem emulate an older modem, which is something you can do on any good modem, but it's not something I demonstrated in my video of the Courier V.everything back a few years ago. And also, the registers you have to set for this particular modem are very strange compared to the Courier V.everything. So I think it's good that I took my time going through and showing that stuff, and I think we learned some cool stuff in the process. And now that I've done all that, I can get this thing packaged off, get it sent to Braden, his first serial modem, maybe his first modem period. So I hope he has fun with that. And I hope you guys have enjoyed watching this video. This is a very cool modem indeed. Just like every Courier modem, it's a nice high quality modem, even for as new of a modem as it is. But I'm glad to be sending it off to someone who will hopefully enjoy it. So thanks so much. I do hope you enjoyed this video. I've got more modem content to come. I've sort of reignited my interest in this stuff just because of the other stuff we've been looking at lately. So I look really forward to showing you guys other cool modem stuff. But until then, I will see you next time.